All right, in this video we're looking at CSEC 2021 paper 2 question 2, but we're at part C. It says make V the subject of the formula P is equal to the root of 5 plus Vt. One of the things that we always want to remember is that whenever we're changing the subject of the formula, we focus on the inverse operation. So what the inverse operation does is that it helps us to move freely on a more logical basis. So whatever you want to get rid of, you do the inverse and balance. For example, in this case, we want to access V. So you could see that V is under the square root. So the first thing that we have to do is that we're going to have to square both sides, which is the left side, and we would have to square the right side as well. And why are we doing that is because the square and the square root cancel each other out. So the inverse of the square root is the square. When we apply it to the right side, we have to apply it to the left side for balancing. So basically we have P squared is equal to 5 plus Vt. So the inverse of the square root is the square. So they cancel each other out, leaving this. The second move is that we intend to leave the subject and anything attached to it for last. So I'm not going to be troubling this yet. All right, so I'm going to be focusing on the 5. So you could see that the 5 here is actually a positive 5. It is actually adding to the right side. So what I'm about to do is I am going to subtract 5. So I'm going to subtract 5 from the right side, okay? So let's see. So basically it's going to be 5 minus 5, and then I have a plus Vt. So as you could see, I did subtract 5 here from 5. But whatever we do on one side, we have to do it to the other side. So I will have to subtract 5 from the left side. So let's write what we have here on the left side. We have P squared minus 5 is equal to Vt. So as you can see, we're almost at the end. All right, it's equal to Vt. So basically, let me write this back quickly, is equal to Vt. We want to make V the subject, so we're going to divide by T and balance by dividing this other side by T. So you could see now that P squared minus 5 all over T is equal to V. And that's how we go through the process in terms of making V the subject of the formula. All right, so let's look on the second part to this question, question 2. So we're looking at part D. It says the distance needed to stop a car is actually, it varies directly as the square of the speed s at which it is traveling. So a car is traveling at a speed of 70 kilometers per hour, requires a distance of 40 meters to make a stop. All right. So basically we're doing variation. So one of the things that we want to do first is to write the formula that will be used to solve all of these problems in this question. So it says that D varies directly, right, as the square, right, as the square of the speed. So a general formula would have been D is equal to K S squared. The K here stands for the constant of the variation, because this is a variation question. Now, if we notice, we would have gotten things that work already. For example, we got S was 70 when D was 40. So we can use this to help us to actually get the constant of the variation. So let us do some substitution here, where 40 is going to equal to K times 70 squared. So again, 40 is equal to K times 4900. So if you divide both sides by 4900, then right here we would have K is equal to, you could break it down if you want, but it's actually 40 over 4900. So we could break it down if we want, or we could leave it. So this is equal to K. So now we know what K is. So having had a value for K, we can do more stuff. So now that I know what K is, I am able to find what is the distance required to stop a car traveling at 80 kilometers per hour. Now I know that K is 40 over 4,900, right? So let us look. We have speed this time, which is going to be 80. I know what K is. I just keep it as 40 over 4,900. And then they want me to find the distance. Well, I'm just going to substitute in the same formula. D is equal to K S squared. D is equal to K, which is 40 over 4,900, and times 8 squared. All right, let's see how much we could go with this. All right, very good. So at this time, we're actually looking at 40 over 4,900 times 80 squared, which is 6400. So D is going to be whatever we're looking at, a distance of 52.24 meters to stop a car traveling at 80 kilometers per hour. Thank you for watching.